All right, now we're going to look at when we have an exponent that is a fraction. And we could call it rational exponents, but I'm not going to look necessarily at, when the exponent's an integer. All integers are rational numbers as well. I'm going to look at specific examples where the exponent, in simplest terms, is not an integer. So here, what I've got written, so our base here is going to be a. We're going to assume that it's a positive real number. And then our m and n are integers, and I'm going to take n to be a positive integer. And we want them to be integers such that m over n is in simplest terms, so it can't be reduced any farther. All right, so if you have a raised to the m over n, there's really two ways that you could write it. You can either write it as the nth root of a to the m power, like we see here, which if we're dealing with our base as a variable, this is probably the better way to write it. But this other way, where I have the nth root of a all raised to the m power, this is probably the better way to write it if a is just a number and we're trying to evaluate it, try to evaluate this without the use of a calculator. Right, but what I want to point out is when your exponent is a fraction, the numerator of the exponent, the m here, is basically the exponent or the power we have. You can see a to the m power, or the nth root of a to the m power. And the denominator of our exponent n is the index of the radical, right? So you can see that's where that goes. And so it's going to follow that same process each time. And so here we're going to look at evaluating some of these expressions that have an exponent that's a fraction. So here we have 9 raised to the 1/2 power. So we want to rewrite this in radical form in order to evaluate. Now we could evaluate this with the calculator, but the point of this video is not to learn how to use a calculator, but actually learn how to apply an exponent that's a fraction and how to evaluate it by hand. So I'm going to rewrite this with the radical, and again, the numerator of the exponent, which is 1, is basically going to be our power that we have when we rewrite as a radical, and the denominator 2 is going to be the index of the radical. Right, so I'm going to go ahead and write down the radical, and you can see I've rewritten it as the square root of 9 to the 1 power. And again, I put the index here too, but if the index of the radical is 2, we typically don't write it actually down. It's just understood to be a square root because it's the most common. To save us a little bit of time in writing, we just assume the 2 to be there. And same thing with the exponent that's 1. Again, we can just write that as 9 and don't have to write 9 to the 1 power, right? So we can just write it the square root of 9. And so now we know that the square root of 9 is 3, right? So we evaluate, square root of 9 is 3. So 9 to the 1/2 power is the same as the square root of 9, which is 3. All right, so let's say we have 64 raised to the 1/3 power. All right, so we need to rewrite this as a radical. So the base is 64, that's going to be our radicand, and it's going to be raised to the numerator of the exponent, which is 1. And the denominator of the exponent 3 is going to be the index of a radical. So it's going to end up being a cube root. So we have the cube root of 64 to the 1 power, or simply the cube root of 64, right? And so we need to simplify this cube root, and 64 is a perfect cube. 64 is 4 cubed, so the cube root of 64 is 4. So 64 raised to the 1/3 power is 4. All right, so let's look at 16 to the 3/2 power. So this is the first example where the numerator of the exponent is not 1, it's 3. All right, so what I'm going to do, again, the 3, the numerator is basically going to be the power. You can put that power underneath the radical, or you can say the whole radical is raised to that power, and that's probably going to be the easiest way to evaluate this. Now, if we look again, Our base is 16, so it's going to be the radicand. The radical is going to be index 2, so it's going to be a square root, and we're going to have it all raised to the third power. Right? And again, you could write it where the exponent is underneath the radical, but again, if I wrote it this way, I'd have to first figure out what is 16 cubed, and that's going to be an extremely large number, and then I have to ask myself, well, then what's the square root of that? So that I don't deal with such a large number, again, it's going to be best, instead of having the square root of 16 cubed, having the square root of 16, and then that whole quantity cubed, like this, all right? And so now, let's evaluate the square root of 16 first, which is 4. So now we're going to have 4 to the third power. And 4 cubed, 4 times 4 times 4 is 64. Right? So applying the radical first, and then that exponent or that power second is going to be a little bit easier. This is because when you take the square root of a number larger than 1, the square root is going to be smaller than the original number. And so we're going to deal with a smaller number raised to a power in the end. So it's going to make it a little bit easier. All right, so let's look at this next example. 8 raised to the negative 4/3. So we have to remember, when you have an exponent that's negative, we need to rewrite it so where we have a positive exponent so we can evaluate. So if you have a whole number raised to a negative power, to rewrite it with the positive exponent, we can say 1 over 8 raised to the positive 4/3. All right, so now we have our exponent written as a positive number. And so now we're going to focus in the denominator and look at evaluating 8 raised to the 4/3. Right? So we're still going to have 1 in the numerator, and we need to rewrite 8 to the 4/3 in radical form. So the denominator of the exponent is 3, so that's our index of the radical. So it's going to be a cube root of 8, and then the whole thing is going to be raised to the numerator of that exponent, 4. All right, so that's 1 over the cube root of 8, all raised to the 4th power. All right, so now we're going to try to evaluate the cube root of 8, and the cube root of 8 is 2, because 2 cubed is 8. So we got 1 over 2 to the 4th power, and last thing we need to do is evaluate 2 to the 4th power. 2 to the 4th power is 16. Right? 2 times 2 times 2 times 2 is 16. So this is going to be 1 over 16.